Hello learners, welcome to this lesson, our physics lesson. This happens to be lesson number 2 of the topic thermal expansion, which is form 4, in which we are going to look at thermal expansion and contraction of solids using cast iron bar breaker. This diagram here you see is called cast iron bar breaker. It's used to show that solids expand when heated and they contract when cooled. It works on the principle of forces of expansion. Forces of expansion and the forces of contraction. So we are saying that expansion or contraction can produce a force. So such a force can be used to break a metal, which is called the cast iron bar or peg. This is also called a bar, but we can just call it a peg if you want. Alright, so basically that we are saying that it can be demonstrated, we can demonstrate that thermal expansion can be used to show, we can show using a cast iron bar breaker to show that solids expand when heated and contract when cooled. Right, so I was saying that this apparatus which you see here works on the principle that when a body expands, it produces a force. We call it force of expansion. Okay, so you have two Bunsen burners here to heat the steel bar. This is called the steel bar. Okay, so it's heated here, it's heated there. The reason why we are using two Bunsen burners is to ensure that the steel bar is heated uniformly, and therefore it's going to produce a uniform expansion. Okay, so it is going to expand uniformly. So it's better to use two Bunsen burners when heating the steel bar than to use one. Why? Because we want this to be heated uniformly so that it expands uniformly. Okay? So the use of the burners, in case they ask you what is the role, what's the use of the burners, is just to heat the steel bar so that it expands. Okay? Okay? And also notice that the apparatus has this part here which is a nut. This is just a nut. The use of this nut is simply to clamp. This is a nut to clamp the steel bar so that it does not shake. Okay, so that it should not shake. This should be firmly clamped. This should not shake. It shouldn't shake. So it is clamped. To stop it from shaking, it should be tight. It should be tight. So it is tightened by the nut. There's a nut here, this one, which is used for tightening. This nut here is to tighten the steel bar so that it does not shake. It's tight, it's clamped, it's held in place so that it should not move freely. All right, so once it is tightened, it can be heated at 2 points using 2 burners. So these are just burners. These are burners. We have 2 of them. I mentioned that 2 burners are ideal compared to 1 because we want this bar to be heated uniformly. In case you don't see this part properly, it's like since it's a 3-dimensional, okay, so it's something like this. Just want to show you. Sorry. Okay. So I was saying that you have something like this. Sorry, I don't have enough space to draw this one, but it will suffice to show you what is going on here. So you have something like this, which represents a steel bar, and then the steel bar has a hole. Has a hole into which a metal, which is iron, is inserted. Into the hole like that. Yeah. So you have something like that. So we are saying that this has to be heated. The steel bar is to be heated. This is steel bar. To be heated while it is tightly clamped. So the heating will produce an expansion. It will cause this to increase in size. So this is going to expand upon heating. So that expansion will cause this to move this way, to expand, not to move, but to expand. The length will tend to increase due to the expansion. Before it goes further, it is blocked. The cast iron bar is blocked by this frame here. Okay, so that it does not continue increasing length that direction. It is blocked. So as a result, it is going to bend. So it will bend, and yeah, it will bend like that. It will bend, and eventually it's going to break. It will break. Yeah, so that's basically the principle in which this works. All right, so in case they ask you to describe an experiment that could be done to show that solids expand when heated and contract when cooled. Okay, so you're explaining this in an exam. Describe an experiment that could be done to show that solids expand when heated. And they are going to specify what apparatus you need to use. So here we are told that a cast iron bar breaker is to be used. All right, so you are glued to using this rather than any other method which you know. Okay, so you say you begin by saying a steel bar is fixed in a frame of a bar breaker. Okay, so by saying that, you have 1 mark. Okay, then the steel bar is locked by inserting a thin cast iron rod in a hole of the steel bar. That's also 1 mark. And notice that it is this cast iron rod which is meant to be broken. So initially we have something like this. And then the forces of expansion will cause this to bend, something like that. So it will bend. And eventually it is going to break, which is the aim of this experiment. But for it to break, there must be forces pushing or acting on it. We call those forces forces of expansion. Expansion produces forces. Okay? All right? So, in this case, the steel bar is clamped strongly. So we are saying the steel bar is clamped. The steel bar is clamped strongly and heated with 2 Bunsen burners. So the steel bar shouldn't be free to shake or to move. It should be clamped strongly. So this is supposed to be clamped or held in place so that it does not shake freely. So the clamping is done by a nut. There is a nut here. Okay. So once it is clamped using a nut, it is heated using 2 burners. We have this burner here, 1, burner 2. So heated there. The steel bar is heated at this point. It is also heated at that point. I mentioned that it's 2 burners are used so that the steel bar is heated uniformly. So this is heated uniformly. And because it is heated uniformly, it is also going to expand uniformly. Okay? That's why 2 burners are used. If only 1 burner is used, it means one side of it is going to be cooler while the other part is heated, and therefore it will not expand proportionally. It will not expand proportionally. Alright? So this is the setup in case you'd love to draw it to support your answer up here. Remember, you're making marks. So you have 1 mark there for saying that, and 1 mark for saying this, and 1 mark for saying this, maybe 2 marks for the diagram. Okay, so already you have 5 marks up to this point. Alright? So the actual bar breaker looks like this. The diagram that we have here is a representation of this actual real picture, the real thing. So if you look at this carefully, this is the steel bar. This is the steel bar, which is to be heated at some point. Usually the burners, 2 burners are used to heat this uniformly to ensure that it is expanding uniformly. So this is to be heated. That's the one which is being heated. Okay, and then this hole here, which you see, this one is this particular hole here. Okay, and then you have the cast iron bar, which is to be broken. The bar to be broken is this one here. I hope you can see it. This is the cast iron bar. Okay, so that's what it looks like, the actual one. Okay, now having done all this up to the diagram, then you go on to explain that the experiment is repeated by strongly heating the steel bar and insert the cast iron rod through the hole and observe what happens to the steel bar. What happens as the steel bar cools. Okay, so we are saying the experiment is repeated. The experiment is repeated by strongly heating. So the steel bar is the one that is heated using 2 Bunsen burners, and then the cast iron is inserted into that small hole which you saw, and then you observe what happens to the cast iron. Remember that your observation is on the cast iron. This is meant to be broken, the cast iron, using the forces of expansion. All right. Now, in due course, as you continue to heat, as the steel bar is being heated, it will be observed that when the steel bar is heated strongly, the cast iron rod breaks with a loud sound. Okay, the cast iron rod breaks with a loud sound. It will break. Pa! Okay, why it breaks is because the forces of expansion are pushing the cast iron rod against the outer frame. By the way, if you go back to the diagram, there are 2 frames here. These are called frames. So this one here is outer frame. This one is outer frame. Sorry. This one here is outer frame. Please take note, frame. And this one is an inner frame. So as the steel bar is being heated, it's going to expand. The expansion will cause the cast iron rod to move towards the outer frame. But before it proceeds, it continues moving. This is going to block it and apply a very huge force which will cause it to break. Similarly, when you remove the Bunsen burners, this is going to contract. There's going to be contraction, and the cast iron rod will tend to move towards the inner frame. It will also cause it to break. Take note of these points that we are raising. So we are saying that it will be observed that when the steel bar is heated strongly, the cast iron rod breaks with a loud sound. When the steel bar is cooled in the repeated experiment, the cast iron also breaks. So in both cases, it's going to break. So the explanation to this is that on heating, when the steel bar is being heated, it expands. Okay, as it is expanding, it pushes the cast iron rod against the outer frame, like I said earlier on, of the bar breaker, and the rod breaks. Okay, so we are saying that upon heating, this is going to expand. There's going to be expansion. This is going to expand because heat causes solids to expand. That expansion will move the cast iron rod towards the outer frame. So the outer frame is going to cause this to break. It will break with a loud sound, loud noise. In the same manner, when this is cooled, we remove the burners, the cast iron rod is going to move backwards towards the inner frame. This is inner frame, and it also causes it to break. All right, that's very important to note. So on cooling, the steel bar contracts and pulls the cast iron rod against the inner frame of the bar breaker, and the rod breaks. So this experiment, or what you have observed here, shows that solids expand on heating and contract on cooling. Without a series of expansion and cooling and the contractions, the cast iron rod could not break, because there would be no forces of expansion or contraction to make it break. So this is what you do explain in paper 2, in case there's a question that requires you to explain how a bar breaker can be used to show that solids expand when heated and contract when cooled. Alright, so the proportion of marks, we already had got 5 marks at the back there in the previous slide, and by saying the experiment is repeated by strongly heating the steel bar, this will also give you 1 mark. And then you have another mark here, another mark, that is 3 already. And then you have 1 mark for saying this, and 1 mark for concluding, 5. So you have 10 marks all together. Wishing you all the best in your paper 2, in case you are asked to describe an experiment that could be done to show that expansion, to show that solids expand when heated and contract when cooled. We meet again in our next lesson. Thank you very much for now. Let me, if you like this video, ask you to like it, to comment, and also to consider subscribing to the channel if you have not done so already. My name is Mr. Pochilola once again, wishing you a beautiful day. Bye-bye for now.